Welcome to the Plant Services podcast series, The Hidden Cost of Compressed Air, sponsored by Kaiser Compressors. Each podcast in this 4-episode series will tackle one of the many facets of compressed air system operation and costing. I'm Tom Welk, the Chief Editor of Plant Services, and today I'm joined by two compressed air experts from Kaiser, Neil Mehltretter and Matt McCorkle, for a discussion on the cost of oversizing your compressed air system. Neil is the engineering manager for Kaiser Compressors, and he's conducted and supervised thousands of industrial compressed air studies to help plant teams achieve significant energy savings and operational improvements. And Matt is the manager of branch operations for Kaiser Compressors and has worked as a certified energy manager through the Association of Energy Engineers. Welcome, guys, and thanks for being part of the special podcast series.
Absolutely. Thanks for having us.
Yeah, it's going to be a great day. I'm excited.
Well, cool. And we'll just tackle the first question right away. Matt, before we press the record button today, we are talking about air system reviews, and you mentioned that your team has found that many systems operate below 50% system capacity. Let's start by asking, can you elaborate more on that?
Absolutely. So what we found is we analyzed 3 years of air study data. And what we found is that on average, customers' compressed air systems are operating at 45% of capacity. So what that means is they have double the compressor capacity that they need to operate on average. And further confirming that 45% number, we've also seen studies done by other organizations that show a similar case, particularly for manufacturing. And they're seeing that the issue is that compressors are really inefficient at partial load. Compressors are efficient when they're fully loaded or when they're off. Really doesn't matter what the control method is. That's generally how it is. And so it ends up there's a lot of waste. And you might think, okay, well, compressors are running at 45% capacity, so folks are sizing them that way so that they can grow into it. So they have kind of a safety factor. But this is generally not the case because most systems are operating with one unit. So if that unit goes down, you have no safety factor, or maybe you're running on an unreliable backup. And so really what's happening is you're operating a unit, a compressor, much harder at part load. Think of it like city driving. So when a compressor is running at 45% capacity, it's like driving in the city versus driving on the highway, which is where you would want your equipment to operate to have maximum reliability, lowest life cycle cost, best efficiency. It's a very similar analogy you can make. And so what that means for customers is they're frequently paying much more for the air they're using than they should be. In fact, we see that the multiple is over a factor of 10. So we see customers that will be spending 30 cents per 1,000 cubic feet for their air. And then we see others that are spending upwards of $3 or more per 1,000 cubic feet. And that's really dramatic when you look at the amount of air used in a manufacturing plant. They're using millions, hundreds of millions of cubic feet of air. And if you're paying 30 cents or $3, that's a huge difference in your budget. So the oversizing causes high costs for air. There's also additional costs for maintenance because you have larger parts, more fluids to change with a larger size compressor. And then you also have the excess capital costs. So instead of buying a compressor that was closer to 100% size, you bought something twice the amount. So, you spent more capital too. So this is what we really try to work with customers to realize, that upfront cost and that planning for the future is an important consideration, but you really want to look at how you're using the air and make sure that you're sizing it correctly. Otherwise, you have these hidden costs related to efficiency, maintenance, and even upfront.
Yeah, and I have really nothing to add. I think Matt hit all the key points. It's an exciting topic for us because we're always looking how we can improve those efficiencies. And it's interesting for me from the engineering standpoint to kind of get in the nitty gritty and the numbers. So.
Well, and Neil, from an engineering standpoint, what are some of the key points that our listeners can look for in their own systems to tell if they're operating their compressed air system at below capacity?
Sure. Matt really hit on the key point. The duty cycle is really what we're looking at when we're evaluating. So duty cycle means, how much time am I loaded versus how much time is that motor on? So, if you're at 50% duty cycle, that's probably the worst place you could run a load-on-load oil-funded rotary screw compressor, which is typically what you'd see in a compressor room. Now, so that's really what you're looking at. If your duty cycle's, say, 70, 80%, that's probably in a better position. We like to size systems so that you're closer to 100%, 90% plus, and that really lends to splitting the load between multiple machines. And we'll talk about that a little bit later. There's a lot of different control types that are out there. Variable frequency drive, or also called variable speed drive. And so you have to look at, does it have one compressor that's meeting the load? And if that's the case with a VFD, typically those are sized so that between 40 and 85% they're most efficient. So that's another number you can look at. And a lot of the machines that are out there can show you these things, duty cycle or percent capacity, and that's a great indicator. There's also modulation and variable capacity control, and either of those can give you a percent capacity as well. Variable capacity is definitely more efficient than modulation. Modulation is probably the least efficient that's out there, but from a reliability standpoint, it could be maybe a little bit more reliable because you can run at partial load and still keep the compressor up to temperature and so on. Efficiency is really the next key point that I'd like to highlight, and we talk about these as a key performance index. So specific power is from an operational or efficiency standpoint is key, and you can look at that for individual compressors. We have Compressed Air and Gas Institute KGI data sheets for those, and that tells you what your efficiency is at full load. But again, like Matt said, 100% or off, and you don't necessarily know what it is in between. And so what we like to say is anything really above 25 kilowatt per 100 CFM, that's where you start to lose your efficiency. If you look at a KGI sheet for a brand new compressor, depending on what operating pressure you're at, you could be at 19 kilowatt per 100 CFM, 17, some of them out there, two-stage, maybe 16. And if it's at 95 PSI, it might be even better. So there are some significant efficiency gains there. So again, specific power is a really good indicator. And then, really, what's your leak load? And so, a lot of cases, Matt alluded to studies that we might do, air studies, efficiency studies, and a lot of customers are also looking at what they're doing on a daily, nightly, weekly basis to see what that leak load might be. Department of Energy has come out with a study that we cite a lot, that 45% to 60% of all compressed air produced is going to production, which means that balance is wasted. So this will help you figure out what that waste might be. Reliability is really another key point. What are your mean time between failures or your mean time between services? And what we find is that equipment that's oversized, they become less reliable, and they may have more breakdowns, more downtime. So if I was a plant manager, first of all, if I had more breakdowns, I'd be trying to figure out what was happening. But that's a good indicator. So if someone's listening to this podcast right now and they're like, you know what, I had a breakdown 2 weeks ago and I just had one today, maybe that the cause is oversizing. Another indicator I would say is a high scrap rate at the point of use. If you have inconsistent operating pressures, that is going to affect your point of use, and that can also increase your scrap rate. And that might be coming back to your compressor room. And one other thing that we talk about is energy, and Matt alluded to it again. Energy, when you look at that pie and your overall life cycle cost, it's 70%. So the more you oversize, the more you're paying for energy, regardless of how much air you're using. And so that would be an indicator, what is your energy cost today for your compressed air, and what is that, over time, or even going backwards in time, and comparing that with what you're making. So we talk a lot about material costs, so you can see what your material costs are over the course of time. I covered quite a gambit there, so I think that covers it. Matt, you have anything to add?
Yeah, I think, what we're seeing in the market, and this I think is pretty exciting, is the key is that folks are realizing in this new age of data and monitoring, they're investing in the monitoring devices like our Sigma Air Manager, where they can consistently see, what level of air they're using and how much it's costing them at any time. So, production is always changing. So just because you're at 40% capacity now doesn't mean you'll be at 40% capacity next month. And, there's certainly plants that are real steady and they have a fixed capacity and it's, their throughput is real established. But more and more, particularly with, the swings that we're seeing in the economy, there's a need to always know, and there's a significant benefit to always know, okay, how much air am I using to run the production lines that I need this week, during this shift? And I think that's really the number one key point is that if you're monitoring your air and you're realizing it's a significant investment, both creating and using this air to run your plant, why not monitor it to know what level it's at and how much you're spending on it?
Okay. Well, Matt, I was thinking, let's say you've got someone in a plant and they're noticing those indicators that Neil talked about, like high scrap rate. They're noticing the material costs are creeping upwards. And they do run an air assessment and they find out that, yes, their system is oversized and they're not using it to full capacity. What now? What at that point are some steps that they can take to remedy the situation?
Absolutely. So the things, I'll start with the low cost to the higher cost. How about that?
Mm-hmm.
So first thing they can do is you can look at your controls. Neil talked a good bit about controls, and the trick is you want to just optimize the amount of time the compressor is fully loaded, and then have a nice amount of time when it's either idled or off. And so you can do that by increasing the pressure band. That would be the cut in, cut out pressure. And you can do that really with multiple different control methods. And that will really kind of stabilize, turn that compressor into more of a highway mode versus more of the city mode. And that's obviously low cost. You wouldn't have to spend anything. You may have to get an expert in there to help you do it, but a few hours of labor time and you'd have that taken care of. The second one is storage. Storage is a great thing for any compressed air system. Again, going to the car analogy, you're looking at the suspension in that car. So you're just kind of balancing out those demands. Neil talked about inconsistent pressure. Increased storage is going to help you stabilize pressure. So storage is generally always a good thing, and particularly good if you have really variable demands or very low demand for a period of time and your system is oversized. Also relatively low cost. And then the third one, a little bit higher cost. A lot of times plants have different loads based on the shift. So you might have a very low third shift or weekend shift, and shift 1 and 2, you're at 70, 80% capacity, but then on the weekends you're at like 20% capacity. And so in those cases, you conduct an air study, and in those cases, you could get a smaller unit to run those off-peak times. And so those are really, I think, the three most common. And obviously, you can also replace your compressor. Depending on how oversized it is, you could replace it. But that's kind of the last resort. Ideally, with some of these other solutions, you're able to get that corrected.
Yeah, I definitely agree with Matt. Doing thousands of audits a year that we do, it's always fun because you talk to friends and family. Oh, well, what do you do? Well, I help save people money. But it's not significant unless you're talking about a 24-hour, 7-day-a-week process with hundreds of horsepower, and the justification, the ROI is just not there. And you have to find an easier way to put it, not just in plain English, but to show that ROI. In a lot of cases, that inconsistent pressure, that scrap rate, that's the heavy addition to make these changes. So, for me, like Matt said, looking at a smaller machine for the weekends, even maybe having a master controller added, these are not higher costs. So if you start talking about 100 horsepower compressor, then you're starting talking, okay, this is a major investment. But the things that aren't a major investment, like maybe an off-peak unit, or adding the storage, or maybe augmenting piping in some places, or the master controller, like Matt said, because when when we're talking now, we're so connected. We might have two phones, both Matt and I, and maybe you, Tom, as well. So the data is there. If you can push that stuff to your computer or your email or what have you, you can see it easily. And it's a way for us to talk on the same level as a supplier and a customer. And that makes it easy to say, well, okay, what was your specific power yesterday? Or what is it today? So that master controller is really that really a key product.
Well, in the past three questions, we've talked a lot about the operational end of things, identifying when your system is oversized sort of in real time. Maybe we could close today's podcast with a question about looking forward to the future. Neil, when you're planning a new plant or expanding an existing system, do you have any advice for our listeners on how to balance their plans for future growth with buying too big of a system? How do they thread that needle?
Yeah, it's never easy. Usually there's so many different players in this discussion, from the project engineer to, maybe even the CEO of the company, or, it also could be an engineering firm. Usually when you start adding all these folks, that you may even get more fudge factors in regard to how much air you expect. And so really the key point when you're starting from scratch, if it's a greenfield, is to design flexibility into your system. And what I mean by flexibility is, sure, we could put in a 250 horsepower compressor for 1,000 CFM, but like Matt alluded to, I think in question one, what happens when that compressor is unavailable, whether it be service or maybe it's a reliability issue? What happens then? So if we look at, two 125 horsepower compressors, or maybe even 3 or 4 different compressors to split that load, especially when you're talking about greenfield and you don't know what's going to happen. It's better to split that load and start smaller than go bigger, because then you end up with this oversizing system. In talking with some colleagues, we usually find that a system that's designed from scratch, that we didn't have any measurement data to start with, a sister plant or something like that, usually after 5 years, we find, if we do an audit, then it's significantly oversized, and we have to change the entire pieces of equipment, and there's significant savings, and we have the ROI for it. And that's not every case, but so my feeling is that baselining the system really from day one, designing flexibility, putting in that master controller, getting those KPIs, getting that feedback is really key. Checking the duty cycle, checking the specific power, looking at the reliability, and then remotely monitoring those KPIs.
Yeah, those are great points, Neil. I mean, it's definitely an engineering challenge when you're building something new and trying to design the compressed air load. There's no there's no model like there is for designing HVAC systems for how to know what size to put the compressors in the plant. But the theme that you're going to hear, I think, in a lot of these podcasts about the hidden cost of compressed air is that going with a flexible design where you have multiple units really reduces your costs from so many different aspects. And again, going to the car analogy, do you want to buy that semi truck for what you've got to ship, day in, day out, or do you want to buy a fleet of vehicles? You're going to have a lot more flexibility if you have a fleet of vehicles, and that, I think, is kind of the model you want to use with designing compressed air stations. And obviously capital, you've got capital at one time when you're building a plant, you want to use it wisely. And I think that's one of the things we see. I mean, it's not uncommon to see a system that's 10 times oversized in a greenfield situation. And that's a lot of capital, put in there. And maybe one day they get to that point, but is that going to be 2 years down the road or 20 years down the road in that particular plant? So designing flexibility in is the real key to eliminate those hidden costs.
Well, thanks, guys. I think that's a wrap for this episode of the Hidden Costs of Compressed Air. For those who are listening, future episodes in this series will cover the cost of location and the cost of air quality, with a 4th episode wrapping up on how to reveal and control costs with system monitoring. So thanks again to our sponsor, Kaiser Compressors. Thanks, Neil and Matt, for being on the podcast today, and thank you all for listening.
Absolutely. Thanks for having us.
Thanks, Tom.